figures correctly in geometry. It is more complicated than you think, but it's really important so that other people understand your geometry work. Let's get started. Here's a diagram with a lot of points on it. If you're naming just a point, all you need is a letter. So point A could be just A, and if I say B, it means that point B. All right, etc. Naming lines requires a symbol and 2 points. Even though there may be more than 2 points on a line, just choose 2 of them. It doesn't matter what 2, since lines aren't directional and they go on forever after they pass through the point. The symbol is a little line on top, which requires arrows at both ends. So AB could also be written BA, that's the same thing. Or you could write BD, that's the same line, just choosing 2 different points. A line segment is a chunk of a line, and the 2 letters you choose are very important because they are the end points. So if you say AB for a line segment, you put a bar on top with no arrows, and that means it stops at A and it stops at B. That is the same as BA, but it is not the same as BD. BD is the line segment that just goes from B to D, and that's it. Okay, so how about naming rays? Rays are the only thing here that are directional. So the order of the letters actually makes a difference here. If I say ray BA, and I put the ray symbol always going to the right on top, that means that the end point is B, right here, and then it goes through A and keeps going forever. That's the ray I'm talking about. If I said ray AB, that means something different. That starts at A and goes forever in the other direction. That's ray AB. Okay? Well, how do we measure line segments and write down the correct label? You would write down AB with no symbol on top, and that means the distance between A and B. That's always equal to a number. So AB is equal to 4 centimeters. If I also added from C to B is 2 centimeters, and from B to D is also 2 centimeters. Since those are equal to numbers, you can actually say that CB is equal to BD. And what this means is that the distance between C and B is the same as the distance between B and D. If we're talking about the line segments being the same figure, we say line segment CB is congruent to line segment BD. We have to use the congruent symbol when we're talking about geometric figures. These are not numbers, they're pictures, but we use the equal symbol when we're talking about numbers. That's an important distinction that you use for all geometric figures and the measures of them. How do we name angles? The most common way is to use an angle symbol and then 3 letters. For example, ABE is the angle right here. Now another name for that same angle would also be EBA. Notice that in both names, B is in the middle. That's because it's the vertex. You have to put the vertex, that point in the middle where the 2 rays connect to make an angle, that has to be the middle letter every time. Now for some angles in drawings like this, you might just have 1 letter that names the whole thing. You can call that angle D because it's not ambiguous. There's only 1 angle in the picture. Even if these are labeled with letters, like let's say that's M and that's N, you can still call that angle D. You can also call it angle MDN or angle NDM. Okay, if you measure an angle, let's say we know that this is 45 degrees, the way we write that down is we put an M in front of the angle symbol. Because it's a number, we use the equal symbol. If we have 2 angles that are equal, for example in the top picture, angle ABE is congruent to angle CBD. Those figures are the same size and shape, so we use the congruent symbol. It's also true that their measurements are the same. So the measure of angle ABE and the measure of angle CBD are both 45 degrees. We can say they're equal because the measurements are numbers. So we use equals for numbers and congruent for figures. The reason I know those are congruent is because they are vertical angles. Okay, so now let's name triangles and other polygons as well as planes. Triangles have 3 vertices and we use them all in the name. You can put them in any order. All of these are the same triangle. If we have 2 congruent triangles, then the order becomes a little more important. Here's an example. I'm going to draw a parallelogram. Let's say that's a real parallelogram and I divide it by the diagonal. And now in my parallelogram, I now have 2 triangles and they happen to be congruent. When I write down my congruent statement, like triangle EFG is congruent to another triangle, I have to be very careful what order I put the angles in. So if I look at the 3 angles here and call that number 1, number 2, and number 3, I have to figure out what order to put them in the other triangle. They have to be congruent angles in the same order. Obviously that obtuse angle number 2 is still going to be number 2. Those ones match. All right, the question is, where are my 1 and 3? Well, what I have is a slightly larger acute angle here and a really tiny acute angle for number 3. So in the other triangle, here's my tiny acute angle. So I'm going to call that the 3rd one. And this is the bigger acute angle, so that's going to be the 1st one. So the order I need to write down for the 2nd triangle is triangle GHE. And now all the parts match that are also congruent. So if you see a congruent statement, then you can assume that the parts that line up are congruent to each other. That line segment EG must be congruent to line segment GE. Well, that wasn't too hard to figure out because they happen to be the same line segment, right? But you get what I'm saying. This order is important. And you need to put the letters in order so that that works. So that's triangles. For other polygons, we don't have separate symbols for every kind of polygons because they're hard to draw when they get many sides. So all you have to do is put the word down. For example, hexagon, MNOPQR, or those 6 letters in order in either clockwise or counterclockwise direction, but not jumping all over the shape. They need to go consecutively around the hexagon. So that's how you name that. Now for a plane, what you need is a minimum of 3 points to define a plane. So if you have some plane in space that has lots of points in it, okay, and all of those are named different things, any 2 of them only defines a line. But if you have 3 points that are all part of the same figure, that has to be in the same plane. And so a plane, what we do is we use a parallelogram symbol followed by 3 letters, and it can be any of those 3 letters. So I'm just going to use those 3, and that's how we label a plane. And those are the basic labeling techniques that we use for geometric figures in this unit and in other geometric contexts.